microprocessor will address the interrupts. So, and we have discussed the architecture of 8259 PIC also. So this 8259 PIC architecture consists a interrupt request register. So this is an interrupt request register. I have already said that 8259 PIC is something which consists of 7, which can address up to 8 interrupts. So it can take 8 interrupts at a time, and it can transfer one after another to the microprocessor. So it has 8 lines of interrupt request register, so which can accept the interrupts. Okay, this interrupt request register will accept 8 number of interrupts from various devices, and then it will it will prioritize these interrupts, and it will transfers the interrupts to the control logic of the unit. So this control logic then, which is connected to a interrupt pin of the microprocessor, will activate say interrupt pin on receiving a interrupt. Okay, so this interrupt, on receiving interrupt, the microprocessor will address the interrupt, and it again send interrupt acknowledgement to the control unit. So this is the overall process which is done in 8259 PIC. Okay, so in yesterday's class we have completed the architecture of 8259 programmable interrupt controller. So next we will discuss about hardware and software interrupt applications. Okay. Can you see the screen? Yeah. So so we have completed discussing about 8259 PIC. Your next topic is software and hardware interrupt applications. So your next concept of your unit is software and hardware interrupt application. So what is an interrupt? So we have discussed as many times as possible about this interrupt concept. What is an interrupt? So unmute your call and speak. Don't message. What is an interrupt? So what is an interrupt? So are you willing to respond or not? Don't waste my time. Okay, fine. So an interrupt is something, yeah. So, did someone responding? Okay, fine. So an interrupt, it's a signal to the processor. Okay, so an interrupt is a signal. So it's also a signal. So this signal will be sent to the processor, which seeks the attention towards the signal. So if the processor, let's say 8086 processor is working on a particular task. So we have a processor, and we have promoted this processor with a particular task. So we have assigned a task to the processor. So okay, so this processor is working on the task which is provided by the user. So meanwhile, if a signal is striking this processor which seeks the attention of the processor towards it, so that signal will called as interrupt. So interrupt is a signal to the processor which will strikes the processor in middle of a particular task. So when the processor is working on a particular task, in middle of this if a signal come to the processor and seeks the attention of the processor towards it, so that signal will be termed as interrupt. So interrupt is also a signal. So it is sent to the processor, that the interrupts from the current processor or the CPU. So the interrupt may be generated internally within the processor, or it may be generated by the external peripherals. Okay, external peripherals. So the interrupt may generate by the microprocessor itself, or the interrupt may come from some external devices connected to the processor. So it's simply a signal which strikes the processor, and it diverts the processor towards its towards addressing it. Okay, so it will whenever the processor is working on a particular task. So let's say the user is provided with a task to the microprocessor, and it is working on that particular task. So meanwhile a signal through INTR pin. So a signal at INTR pin of the microprocessor will activates the microprocessor interrupt request, and it will seeks the attention of the microprocessor towards this signal. Okay, so the microprocessor stops or prevents the task which is working on, and it will address this signal, and again it will continue the original task. So this is the process which this microprocessor undergo when a interrupt signal will strike on it. So interrupt is nothing but it's a signal. So it may be developed internally by the microprocessor, or it may be generated by external peripherals. So it's an interrupt signal, so which strikes the microprocessor, may be generated internally by the microprocessor unit. That means either by the arithmetic logical unit, or either by the control and timing circuit, either by the registers. So these are the internal components of the microprocessor. So these three are the internal components of the microprocessor. So whenever the interrupt is generated by any of these three components, so then the interrupts are termed as internal interrupts. Okay, so the microprocessor is connected to the different units externally. So input unit, next memory unit. So it may be connected with some controllers, some external output unit. So these are the output peripherals. So if the interrupt is from any of these devices that are connected externally to the microprocessor unit, then it is called as external interrupt. Okay, so interrupt may be internally generated by the microprocessor unit, or it may be from the external peripherals connected to it. Okay, so interrupt is simply a signal. So it's a signal to the microprocessor unit which seeks the attention of the microprocessor towards it. Okay, so it seeks the microprocessor attention towards it. So whenever it is working on a particular task on a current execution, so whenever it is working on a current program execution, so it will the interrupt will prevents the microprocessor to execute this program, and it will diverts the attention of the microprocessor towards this interrupt signal. So the microprocessor will stops this current execution, and it will address the signal. So that is nothing but the interrupt signal. So it will address the interrupt signal. That means it executes this interrupt signal, and again it will address the signal. So this is the Am I audible?
Yes, ma'am.
Yes,
Okay.
madam.
Sorry for the inconvenience. I was out of the meeting actually. So now I'm audible, right?
Yes, ma'am.
Yes, madam.
Okay. So screen is visible, right?
Yes, ma'am.
Okay. So here you have two types of interrupts that strikes over microprocessor unit. So one is something which will be generated within the internal components of the microprocessor. So what are the internal components? Arithmetic logic unit, resistors, and control timing circuit. So these are the internal components of the microprocessor. If ever the interrupt is generated within this these components by these components, then those interrupts are called as internal interrupts, or these are also called as software interrupts. Okay, so these are also called as software interrupts. So within the uh, within the microprocessor, if the interrupts are generated, so then those type of interrupts are called as software interrupts. So nothing but software interrupt is the interrupt that is generated by any internal system of the computer. So if you consider this as your supercomputer, so if at all any internal system of the computer generates the interrupt, so any internal system of the computer, so the interrupt generated by any internal system of the computer is called as software interrupt. So what do you mean by hardware interrupt now? So a hardware interrupt is generated from any external devices. So that means here we are connected this unit to input devices, memory unit, so some controllers, some output unit. So these are all the external devices connected to this microprocessor unit. So if at all any of this external device generate a particular interrupt signal, so then those are called as hardware interrupts. So these units are called as hardware units, and the interrupt generated by these hardware units are called as hardware interrupts. Okay, so these are the hardware units, and these interrupts are called as hardware interrupts. Okay, so this is about this is how we can define a software interrupt and a hardware interrupt. So we have two kinds of interrupt. So interrupt is a signal, so which can be addressed by a microprocessor unit, which seeks the attention of this microprocessor unit towards that particular signal. So even if the microprocessor is in idle state, or it may be executing or performing a particular task. So whether the microprocessor is in idle state or in a busy state, so whenever the interrupt strikes on a microprocessor unit, the microprocessor will works for that interrupt. Okay, so it will address that particular interrupt. So even if it is idle state, it will takes place the action for the interrupt, or it is in a particular, it is executing a particular task, or it is busy with executing a particular program also, it will stops the execution and it will address the interrupt, and again it will come back to the current execution task. Okay, so interrupt is a priority signal. So it is a priority signal, so which strikes to the microprocessor unit. So these interrupts may be generated internally by the microprocessor unit. So that means whatever the components that are present in the microprocessor unit are responsible for generating these interrupts. Okay, so those are called as software interrupts. So if the system components generate an interrupt, so then those are called as software interrupts. So whether if the interrupt is generated by any of the hardware component connected to the particular system, so then those interrupts are called as hardware interrupts. Okay, hardware interrupt is often created by these input devices such as keyboard or mouse. So let me explain you about this hardware and software interrupts in brief. So let's take keyboard and mouse are the some input units. So keyboard is one of the input unit and mouse is also one of the input unit, and let's see if an interrupt is generated by the input unit of the microprocessor. So the hardware interrupt is often created by the input unit of the processor. So it is, let's say, keyboard and mouse are the devices which are responsible for generating these interrupts. So hardware interrupts are often caused by the hardware components of the microprocessor unit. So whatever the hardware components that are connected to the unit, so if at all those units are responsible for generating these interrupts, so then those are called as hardware interrupts. So here the hardware interrupt is caused by some hardware unit such as input unit. So when this interrupt will caused, so whenever there is a particular problem with this particular input unit, so whenever there is a failure in this hardware, so so let's say there is some failure in this input unit, that means in this hardware component there exists a failure or something similar to the failure. Okay, so some components of this particular unit got failed. For so let's say keyboard, so if you are typing something, some of the internal connections of the keyboard has got corrupted and we are not able to type, but we are typing. So in that case, these input units, so this hardware interrupt will be generated. So this unit will generate a particular signal. Okay, so this hardware interrupts were introduced then. So whenever there exists a problem or a failure or something related to that, so in a particular device, so that device will then introduce a signal. So that signal will be strike to this microprocessor unit through this INTR pin. So that means whenever there is a disturbance in the particular unit, then the interrupt will get generated. Okay, so this hardware interrupt were introduced in a way to avoid the wasting of the processor's valuable time. Okay, so it will generate an interrupt in order to avoid the wasting of this time of this in processor. Okay, the processor should not waste the time by waiting, so that it may get some input from this input unit. So in order to make the processor to know that the input unit is not capable of providing such instructions for execution, so it will simply generate a interrupt signal to the processor. So the processor will address those interrupt and it will come to know that, so there is a problem with the input unit and I have to fetch the data from the memory unit or something else, and I have to go through the process. So it will an interrupt may also use it to make the processor to know that there is a disturbance in the particular unit connected to it. Okay, clear?
Yes, ma'am.
Okay, so next, not only that, there is something else which also can generate the interrupt. So, for example, if you are using the word, if we are using a word processor, okay. So, if we are using a word processor and we are typing in that word processor, so that means we are pressing the keys of the keyboard and and we are typing the program. Okay, we are typing the program. So whatever the program we want to execute by using this microprocessor, we are typing the program in a word processor. So and we are pressing the keys. So type చేస్తున్నాము అంటే keys use చేస్తాం కదా నాన్న. So we are typing the keys of the keyboard. So if the input if something let's say we are typing something called microprocessor. Okay, so microprocessor, so this is what we want to type. So it creates how many letters are there? 1 2 3 4 5 14. Okay, so it will create 14 interrupt requests. Okay, so when we are typing a particular word or a particular information or particular sentence of a program, so that means whatever the number of letters in that particular sentence will create a interrupt. Okay, so it will create as many as interrupts which indicates the number of letters in this total word. Okay, here the microprocessor consists of 14 letters, and it may generate 14 interrupts. Okay, so it may generate 14 interrupt requests, which allows the program to display this word microprocessor. Okay, so it will create 14 interrupts to the microprocessor unit, which allows the program to display this word microprocessor. So that means which allows the program to display the words we type, so the letters we type. So that will, each letter will be displayed to the user by creating an interrupt to the microprocessor. So this is how the interrupts may also created within the microprocessor unit. So whenever we are typing a particular sequence or of letters by using a program using a word processor, so that many number of interrupt requests may be generated to the microprocessor unit in order to display the word we type. Okay, similarly, each time when we click a mouse button, so when we are using a mouse, and we each time when we tap the button of the mouse, for each touch an interrupt may generated. So this is condition of may, so may or may not be generated. So for each touch of the mouse unit, so for each tap of button on the mouse unit, it will generate an interrupt. Suppose, let's say, we are working on a system. So let's say this is your system, and we haven't worked for a few seconds. Okay, for few seconds we have not done anything for anything with this system, but the system is in on state. So once if you use the mouse and if you click this mouse button, so this system will get activated. Okay, so this system activation will be done by an interrupt signal. Okay, so this is also may be done by an interrupt signal. So by generating an interrupt signal to the system gets activated, and it will verifies whether the task is performing on the system or not. Okay, clear?
Yes,
So
ma'am.
if you are using your mobile phone, right? So mobile phone యూస్ చేస్తున్నప్పుడు ఒక 5 seconds 10 seconds మీరు దాన్ని యూస్ చేయకుండా ఉంటే ద స్క్రీన్ ఆఫ్ అయిపోతుంది కదా నాన్న. సో స్క్రీన్ ఆఫ్ అయిపోయిన తర్వాత అగైన్ when we tap on that screen, it will light again. So it will come to the original state again. So అలా ఒరిజినల్ స్టేట్ రావడానికి మేబీ ద ఇంటరప్ట్ మే బి రెస్పాన్సిబుల్ ఫర్ దట్ changing of states of the system or a mobile phone. So when each time when we are using a particular device, so that will generate a interrupt to the system, that will may generate an interrupt to the system. Clear? Clear?
Yes, ma'am.
So how this interrupt will send to the processor? So let's see how this interrupt, so interrupt అనేది produce అవుతుంది. How this interrupt will be transferred or sent to this processor? Let's see now. So if we are working on a processor, so an interrupt has been generated for that processor. So let's say again take an input unit. So we have generated an interrupt from the input unit to the microprocessor unit. Okay, so this input unit which is connected to the microprocessor unit has generated an interrupt. So this interrupt will be now sent to the microprocessor as an interrupt request. How it will not directly go, so it will generate a interrupt request. Okay, so it will generate an interrupt request, so which is called as IRQ. Okay, so interrupt request will be generated by the interrupt produced by this particular device. So whenever the interrupt signal is generated, each input device has an unique IQR. Okay, so each input device has a unique IQR. So IQR is nothing but interrupt request. Okay, so IRQ. So each input device has a unique IRQ, interrupt request. Don't confuse, this is interrupt request short form. Okay, IRQ is the interrupt request short form. So each input device which is connected to the microprocessor unit will have a unique IRQ. So by setting this by taking this unique IRQ into consideration, So if number of interrupt, so if one interrupt is generated at a time, so the interrupt will be simply transferred to the microprocessor unit through this interrupt request. Okay, so it will generate an interrupt request, and this interrupt request at processed by this microprocessor unit by interrupt pin. Okay, so this interrupt request will be sent to the interrupt pin of the microprocessor unit, and this microprocessor unit will address the interrupt, will execute the signal which is present on this interrupt, and it will generate some interrupt acknowledgement. Okay, so this interrupt acknowledgement defines that the microprocessor has addressed this particular interrupt. So if only one interrupt is generated at a time, so this is the process. So interrupt from where the interrupt is being generated, from which device the interrupt is being generated, that will send a IRQ interrupt request to the unit which is connected to this microprocessor, let's say PIC controller. So PIC is the thing which is connected to the microprocessor in order to transfer the interrupt to the microprocessor unit. So this request will be received by this PIC unit. So this PIC unit will now transfer this request to the microprocessor through INTA pin. Okay, so this has a control circuit. So through this control circuit, it will transfer the interrupt request to the microprocessor through INTR pin. So this INTR pin activation of will indicates the microprocessor that it has to address an interrupt. So it will come to this, it will accept the interrupt, and it will execute the interrupt. So the microprocessor unit will execute the interrupt. So after executing the interrupt, the address of the interrupt will be stored in interrupt service routine. So here we are getting the interrupt from this input unit. So this input unit asks this PIC to send whether the interrupt has been executed or not, to send the report whether the interrupt has been considered by this microprocessor or not. So that in order to provide that thing to the input unit, so the address will be stored in the ISR, and the microprocessor will send this information that the interrupt has been executed, and the address is stored in ISR, that will be sent to this controller again through this INTA pin. So this INTA pin activation indicates the PIC controller that the microprocessor has executed the interrupt, and again after getting an interrupt acknowledgement, it will return that acknowledgement to this input unit that your interrupt has executed by the microprocessor unit. So that is the message to this input unit. So if input unit wants, it will verify the ISR, or else it will do not verify. So it's up to the input unit or the user interest. Okay, so this is how the process is going on for the execution of a microprocessor unit. So this microprocessor unit
Am I audible?
Yes, ma'am.
Yeah.
Okay. So let's say we have three different inputs from three different input devices. Okay, when we are having number of inputs from a number of input devices, so as I said you, an input device has IRQ. So each input device has unique interrupt request register. So each input unit will have a unique IRQ. So each device has a unique IRQ, which will be set by the PIC controller that is connected to the microprocessor unit. So this PIC will receives all the interrupts. So here in PIC we have IRR. So what is IRR? Interrupt request register. So all the interrupts will be received by this PIC and the priority resolver. So this PIC have priority. So this PIC also have a priority resolver. So this priority resolver will prioritize these interrupts based on this IRQ status. So what defining the interrupts by this microprocessor will the PIC. So this PIC will prioritize the interrupts. So how this so all the interrupts are from input units only. So we have three input units. So all the three interrupts are from input unit. So this cannot prioritize the interrupts based on the type of device. Okay. So based on the based on the type of device, this priority resolver will prioritize the interrupt. But unit. So the interrupt is from input unit. So but every input unit has a unique IRQ. So interrupt request. So this unique interrupt request basis based on this unique interrupt request. So this priority resolver will prioritize the. It will set a priority for this interrupt. Okay. So this all these three interrupts will get prioritized based on this unique IRQ. So this based on this unique IRQ, this priority resolver sets the priority to the interrupt. Okay, so the interrupts will get prioritized based on unique IRQ of the input device. So after setting this priority, so then the signal having the highest priority will be transferred to the microprocessor first. Okay, so this PIC controller will transfer the interrupt with highest priority to the microprocessor unit. So this priority resolver, by setting this priority, prevents the conflicts and ensures the common input devices. Okay, so it will this priority resolver now setting this priority. So on setting this priority, it will resolve the conflicts. So it will prevent the conflicts. So here, let's say keyboard is one input device, mouse is one input device, and another input device is some scanner. So all these three are input devices. So the interrupts are from all the input devices. So we have interrupt from keyboard, we have interrupt from mouse, and we have interrupt from the scanner. So these are the input devices, and we have the interrupts from the input devices. So this cannot give a particular priority based on the type of device, since these three are the input devices. Okay, since these three are the input devices, but based on the unique code having by this particular device, it will set the priority. So as it sets the priority, it will prevents the conflicts and ensures the common input devices such as keyboard, mouse, etc. can get prioritized. So this is how the remaining process will be same. So after receiving the interrupt, it will handle the interrupt and it will store the interrupt in ISR. So interrupt request address. So this is interrupt service routine, which consists the address of the interrupt which is being executed by the microprocessor unit. Okay. So after setting the interrupt ISR after setting the interrupt service routine. So INTA pin of the microprocessor will get activated, which makes the PIC to know that the interrupt has been executed by the microprocessor. Next, again, second interrupt will get transferred to the microprocessor unit to INTR. So again, after executing, ISR will be generated and INTR pin will get activated. Next, third interrupt, it will send the third interrupt. So this is how the process will rotate. Okay, so if there are number of interrupts from a common input unit, from a common unit, let's say input unit, so this is how the interrupts will get prioritized. So based on the IRQ, interrupt request, which is present within the particular input unit. So every input unit has a unique IRQ. So based on that IRQ only, so the interrupt will get prioritized and it will send the interrupt one by one to the microprocessor unit based on this priority. So this is about hardware interrupt. So whenever we have an interrupt from the external device to the microprocessor, this is how the process will go. Okay, so this is how the process will go. Okay na, అర్థమైందా?
Yes, ma'am.
Okay, so next you have something called software interrupts. Okay, so software interrupts are generally provided by the internal system units of the computer. So whatever the internal system units present here for a microprocessor unit and arithmetic logic unit, register and control and timing circuit. So these are the internal components present in the microprocessor unit. So whenever we have an interrupt from these devices, from these units, so whenever we have an interrupt from these units, from internal units of the microprocessor, so then they are called as software interrupts. Okay, so then those interrupts are called as software interrupts. So what is the purpose of this software interrupts? Why software interrupts will get generated by this internal unit? So these software interrupts are used to handle the errors. Okay, handle the errors. Okay, so whenever there is an error in the program, so suppose let's say the microprocessor unit is working on a program. So it is working on a program, it is executing a particular program which is defined by the user. So whenever there is a error in this particular problem, whenever we can see an error in this particular program, so error in the program, so then immediately the internal components will generate a particular interrupt. Okay, so whenever they observe a particular error in the program, so they immediately generate an interrupt. Okay, so this is why the internal components will generate the interrupts to the microprocessor unit. So in order to handle the error and expectation that there will be an error to the microprocessor unit, so then the then the software components, then the internal components of the microprocessor unit will generate a particular interrupt. So in order to handle the errors, okay, so whenever this microprocessor is performing a or executing a program defined by the user, so if at all there is an error in the program, if at all it is observed that there is an error in the program, then immediately the internal the internal units so which is working on this particular program will raise a interrupt. Okay, so in order to handle the error. Okay, so software interrupts are used to handle the error, and it may also generated, so this interrupt may also generated if the unit which is performing this particular program expects an error. Okay, సో ఎర్రర్ వచ్చాక రెస్పాండ్ అయ్యి ఇంటరప్ట్ ఇస్తారు నాన్న ఒకటి. నెక్స్ట్ ఇఫ్ ఎట్ ఆల్ ఎర్రర్ వస్తుంది అనే ఒక ఎక్స్పెక్టేషన్ ఉంటే యూనిట్ కి, సో దెన్ ఆల్సో ఇట్ విల్ రెస్పాండ్ అండ్ ఇట్ విల్ జనరేట్ అన్ ఇంటరప్ట్. సో దేర్ ఆర్ టూ కేసెస్ ఇన్ ద సాఫ్ట్వేర్ ఇంటరప్ట్స్ అగైన్. సో ద ఇంటరప్ట్ విచ్ ఇస్ generated when there is an error in the program, and the interrupt which is generated when the device, when the unit which is handling the program expects an error. Okay, so these are the two types of errors again. So whenever we are talking about something called software software interrupts. So again, in the software interrupts, you have two types of interrupts. So these software interrupts are mainly used to indicate or to use it to handle the errors of the program. So errors of the program on which the system is working on. So whenever we are talking about this software interrupt, again we will come across two cases. So one is the interrupt which is generated when there is error in the program. So when there is error in the program, so responding to that error, the particular unit which is working on the program will generate an interrupt. Okay, so this is one of the interrupt. And if the unit expects an error, so then also the interrupt will be generated. Okay, so if that the software interrupts are used to handle the errors of the program. So and the interrupts are generated in such a way that if there is a interrupt in the program, then the unit which is working on the particular program will generate an interrupt. So that is one case. So if the unit expects an error in the program, so then also the interrupt will get generated. So these are the two cases where the software interrupts will get generated by the internal units of the microprocessor. So here I am considering the program. So the program execution unit, so EU. So the program execution unit will develop these interrupts. Suppose if the program, so let's say this is not a program, so this is an arithmetic operation. So if the microprocessor is performing an arithmetic operation, so then ALU will respond and it will generate an interrupt for this particular operation. Okay, so if there is an error in this particular arithmetic operation, ALU will respond. So here I'm considering a program. So the execution unit of the processor will respond and it will generate an interrupt. So for example, so if some clock problem, so we have some clock signals, right? So some clock signals are present within the microprocessor unit, and if the clock doesn't run well, so that means it is not in synchronous with the other system clocks, so then the clock and timing circuit, so the clock and timing circuit will respond and it will generate an interrupt. Okay, so these are the interrupts which are used to handle the errors in a particular task performing by the microprocessor unit, and these interrupts will be generated internally. So internally these interrupts will be generated and these are used to handle the errors. Okay, so it allows the so these interrupts will allows the microprocessor to be safe. So it will allows the microprocessor to not get crashed. Okay, so interrupt which is generated by the internal units may responsible for the program to not get crashed. Okay, so it will make the program to not get crashed. It will simply show the error and the user can rectify the error on that interrupt signal, or the microprocessor itself can rectify the error, and again the process will be carried out. There will be no term of crashing the program or crashing the device. Okay, so it prevents the software interrupts prevents the device from crashing. Okay, it will prevent the program from crashing. So an interrupt and a software interrupt may be generated in order to prevent the program or the processor from crashing. So it allows the program to change the course and handle the error. Okay, so it will itself handle the error. So it will simply change the course and handle the error before continuing. So if at all it's a 4-line program, if there is an error in the second line, before going to the next line, it will change the course and it will handle the error. So this error will get rectified, and again the next line will be executing and the continuing of execution will be done. So similarly, an interrupt can be also used to break the infinity loop. So if we are using an infinite loop in the program, so if we want to break the infinite loop which could create a memory leak, so this infinite loop may create some memory leak. Okay, So memory leak. So if you want to break this infinite loop within the program, so then also this interrupt will get generated. Okay. So the interrupt may be generated in order to break the infinite loop, which could create the memory leak. Okay. So this cause a program to be unresponsive. Okay. So this memory leak will make the program that it may affect, it may crash, it may it may be unresponsive. So it will prevents the breaking of this infinity loop, prevents the unresponsive of the program. Okay, so this is how the software interrupt will get generated, and the reason why the software interrupt get generated is to handle the errors that are present in the program. So again, the next reason is to break the infinity loop of the program. So if in the program we have an infinity loop, this may leads to memory leak. Okay, so memory leak which makes the program unresponsive. So this unresponsive nature of the program can also be managed by using this interrupt. So there will be no unresponsive in the programs if the interrupt will get generated and this infinity loop will get breaked. Okay. Okay, so this is about software interrupts. So software interrupts will be generated simply by the internal, any of the internal units of the system, and this is used to handle the errors in a particular system. So whenever there is an error, whenever the system is expecting an error in the program or the task it is going on, so then a software interrupt will be generated. Clear?
Yes, ma'am.
Clear. So how the software interrupts will get processed? Same as hardware interrupts. So the software interrupts are also processed same as this hardware interrupt. Same as this, same in this manner only the software interrupts will also get handled. So both hardware and software interrupts are processed by a interrupt handler. Okay, interrupt handler. So the interrupt handler will handle, so it is nothing but interrupt service routine only. Okay, so interrupt handler is nothing but an interrupt service routine. So interrupt handler, both software interrupts and hardware interrupts will get accessed by the interrupt handler, will get processed by the interrupt handler, which is called as interrupt service routine. So when the processor whenever the processor receives an interrupt, whether it may be a hardware interrupt or a software interrupt, whenever the processor receives an interrupt, it will generate an interrupt service routine. So interrupt service routine will be generated by the processor that indicates that the processor has handled that particular interrupt. The processor has executed that particular interrupt. So the interrupt address will be stored in this ISR. So after ISR generation, INTA pin will get activated, which indicates the external devices or the internal devices that the microprocessor has executed the interrupts. Okay, so whenever the ISR is generated, the microprocessor pauses the actual it will pause the actual operation. It will handle the interrupt and again it will resume as the uh, actual process which it is going on. So here the software interrupts or the hardware interrupts will be executed by the microprocessor unit less than 1 millisecond. So since these are the strokes of mouse or the strokes of the keyboards, these are similar to the strokes of mouse or keyboard, either it may be a software or hardware interrupt, it will be handled by the microprocessor unit within less than a single millisecond. Clear? So this is how the software interrupts will get generated and handled by the microprocessor unit, and this is why the hardware interrupts will get generated. So both interrupts are handled by the microprocessor unit by interrupt handler, which is called as interrupt service routine. And again, after handling the interrupt, it will generate a interrupt acknowledgement. Okay, clear? So either it may be a software interrupt or a hardware interrupt, it will prevents the microprocessor unit from crashing. Okay, so it will not make the microprocessor to be in tough situations. So it will always helps the microprocessor unit. Clear?
Yes, ma'am.
Do you have any doubts?
No, ma'am.
No. So if you have any doubts, you can reach me on call or WhatsApp. Okay. Let me take the attendance. Shravani, do you have any doubt?
No, ma'am.
So you just raise your hand. So అందుకనే అడిగాను. So you are clear with today's concept, right? అరే ఏం అడిగానమ్మా, ఈరోజు కాన్సెప్ట్ అర్థమైంది కదా అని అడిగాను.
అర్థమైంది మేడం.
Okay, so let's continue our class tomorrow. Just a moment, Nana, don't left. I'm taking the attendance. Okay. Thank you.
Thank you, ma'am.